So this is a easy problem. This says we have a proton and we have an alpha particle. After being accelerated through same potential difference, so we have some potential difference in a space. So let us say this region of a space contains some potential difference, and so this is potential V1 and this is a potential V2, and there is a potential difference. Two particles are accelerated through this potential difference. So let us say, and the emerges from this. So I can say there is a particle that is emerging from this potential difference with some velocity. It will gain some velocity. So let us say V is the velocity, and delta V is the potential difference between these two plates. So delta V is the potential difference. Now this is after this enters a uniform magnetic field. So here you have some magnetic field. So this you have some magnetic field uniform. So there is a uniform magnetic field which is perpendicular to the velocity, of course. So this velocity is this side and this is the inward side of the plane of paper. So you see velocity is in x direction, and this is your y direction, and this is your z direction. So magnetic field is basically minus k direction. So B is towards the minus k direction. Are you getting or not? So this is B is basically minus k direction. Find the ratio of radii of the circular path of the two particles. If you remember, if a charged particle moves with velocity v in a magnetic field, this follows circular. So now I know path is circular. So this is easy to understand. So path is circular. Path is circular. Now if I know the path is circular, I also know what is the radius, and radius is given by r is equals to mv by q into v. Are you getting or not? So r is equals to mv by qv. What is the velocity of alpha particle? You have one particle is alpha particle, another particle is a proton. So let us first find velocities of these particles. So how will you find velocity? So let us say velocity. So to find velocity, this is the only thing we have to do. So velocity, let us say first for alpha particle. So you see, if this goes from here to here, there is a increase in potential energy. Let us say this is higher potential than decrease in potential. So this plate is at higher potential, this plate is at lower potential. There is a decrease in potential energy, that is Q into delta V, and that should be equal to increase in kinetic energy. So now I can write decrease in potential energy, decrease in potential energy is same as gain in kinetic energy. So this is equals to gain in kinetic energy. Now I know the decrease in potential energy is Q. Let us say for alpha particle, Q alpha into delta V potential difference. This is equals to half m b alpha whole square, half m b square. Now if you calculate this v alpha, so what is this v alpha? And mass of the alpha particle, m alpha. So from here I can calculate v alpha. V alpha is nothing but 2q alpha into delta v, and this divided by m alpha under root. So this is my v alpha. Are you getting or not? So what is radius? So radius of alpha particle will be mv by qv. So m alpha v alpha divided by q alpha, and b is constant. So either it's alpha particle or it's a proton. For both cases b is same b, because b is a function. B is not a function of a space or particle, it's a constant. Now m alpha is m alpha, v alpha we have already calculated. So this is under root 2q alpha and delta v, and this divided by q alpha and b, and I have to have under root m alpha. Now if you solve this one, so what this value comes out to be? So if you solve this one, you will have q alpha in the denominator and m alpha in the numerator. So you will have 2 m alpha delta v to m alpha delta V, and this you will have Q alpha. This is all in the denominator, and this B is outside the root. So you see this is this multiplied by 1 by B. So check yourself, you will get the same thing. So what I have to do, I have to simply cancel this m alpha. So you will have under root m alpha on the top, and Q alpha goes, so you will have Q alpha under root in the bottom. So this is for radius for alpha particle. So simple. So radius for alpha particle is given by under root 2m alpha delta V divided by B under root Q alpha. So again, radius for proton I can write same way. Only thing is, in place of alpha I can write proton. So 2m proton delta V, and this divided by B, because B is constant, under root Q of proton. Now if I divide these two things, I can get the basically what is the ratio of alpha particle divided by proton. So this is equals to, so you will have under root 2m alpha delta V, and this divided by B under root Q alpha, and this multiplied by under root 2m proton delta V, and multiplied by B under root Q proton. Now B goes, so if you see, if you cancel all this term, you will have simply on the top you will have under root m alpha Q proton, and on the bottom we will have m proton and Q alpha. So this is the ratio. So you see, what is the alpha particle? Alpha particle is helium plus plus. So now I know, so this is the helium plus plus. So what is helium? So you have helium, hydrogen helium, and helium has 2 proton and it also has 2 neutron. So mass number is 4. So now I can write, so this is m alpha is 4 and m proton is 1, only 1 proton, and Q proton is again 1, and Q alpha helium plus plus is 2. So this is R root 2. Or if somebody asks Rp by R alpha, then you will have 1 by root 2. So Rp by R alpha, that is 1 by root 2. So this is the ratio you have. If you throw the two particles in the same magnetic field with a same potential difference, what is the ratio of their radii? That is 1 by root 2. So check here. Yeah, this is the ratio of Rp by alpha, R alpha. So you see the answer, Rp by R alpha is 1 by root 2. So Rp by R alpha, Rp by R alpha is 1 by root 2.